Okay, so the second part of this lesson is to model data using polynomial functions. We have a real-world example. So it says you can use a graphing calculator to model the data and exhibit linear, quadratic, cubic, and quartic behavior by first examining the number of turning points suggested by a scatter plot of data. So we're given some information, and it says refer to the beginning of the lesson. The average personal savings as a percent of disposable income in the United States is in the table. So this is the graph that we're given. So we'll just have a look. So the turning points are when we notice the difference between the increase and decrease in values. So we can see that this is going to be quadratic. So we're going to use an online graphing tool for quadratic regression. So using this is the I think it's called Kelson Online Calculator by Casio. So I've clicked onto quadratic regression and I've typed in the values. So from 1970, we're looking at the distance in years. So 1970 is 0 years away, 1980 is 10 years, 1990, 20 years, 1995 is 25 years, 2000 is 30 years, 2001, 31 years, 2002, 32, 2003 is 33, 2004 is 34, and 2005 is 35. So we've executed our values, and then it produces a table of values and this graph. Now we can see from this graph it's quadratic and the points are all plotted for us. And we can see, looking at the correlation, 0.98, it is a very strong correlation. So it is a good fit for our graph. Now the formula for quadratic regression is shown here. Y is equal to a plus bx plus cx squared. And we're going to use this table of values. We're going to write our polynomial function. So just going back here, and I've saved, and I'll just move this information up. So we can see our data. So we now need to write a polynomial function. So we're looking at this formula here for quadratic regression. So our polynomial function to model this data is going to be a, and a is 9.744. So we're going to just take the first 3 decimal places, or the nearest thousandths. So 744, and this is plus b. So b is 0.0. So 0.033 to the nearest thousandths, and this is x. And then we have our c value, which is minus. So this is going to be plus or minus. So change this to a minus. And this is going to be 0.00. Now we've got 86. So I'm going to round this to 9x squared. I'm just going to rewrite. So we write it in with our x squared first. So we've got minus 0.009x squared plus 0.033x plus 9.744. So this here is our polynomial function. So the next part of the question, we're asked to model and estimate. So let's write this down. So we're asked to model and estimate the percentage in savings in 1993. So we need to say how many years difference. So from 1993 to 1970, this is 23 years. So we're going to use f of x, so f of 23 into our formula. So we've got minus 0.009 23 squared plus 0.03323 plus 9.744. However, if I work this out, because I've rounded my answers, it's not going to be very accurate. So we need to go back to our table of values, and we need to use as many of these numbers we've got to 10 digits here as possible to ensure we have a very accurate answer. So after 23 years, putting this into the calculator, we will have 5.94, which is 5.94 2, but we're just going to round it. Okay, so after 23 years, and then we can say that this savings, so 23 years later, so 23 years later, so this is in 1993, the percent savings is 5.94%. So the final part of our question, it says use the model to determine the approximate year in which percentage savings reached. So we want to find an estimate of the year when savings reached 6.5%. So let's go for red. So we're looking at, so this is going to be 6.5. So if we draw a line, so it's going to be a bit tricky for me to draw a line across. So if I was able to do this on a graphing calculator, we could do this by intersecting at 6.5. So this is going to be, if we read off our value from here, this intersection, and I read down, this is going to be approximately 21. So this is when x is approximately 21. So this is 21 years later. So if we say 1970 plus 21, so this will be in 1991. Savings was 6.5%. Okay, so the next question we have is about population. And this is the median age of the population by year predicted through 2080 is shown. So if we look at our data, there is an increase. So let's just, so from here, this is increasing, 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 increasing. So this is going to be linear. regression. So the question says, write the polynomial function to model the data and let L1 be the number of years since 1900. So we're going to put in our data into our table. So 1900, so the first is going to be 0 and 22.9. And then we have 1930, so that's 30 years later. So we're going to use 30 and 26.5. Third bit of data is 60 years since, so that's 29.5. The fourth piece of data, 1990, is 90 years later, and this is 33.0. So we're looking at 30 years later. 130 years later. 120 years later. And 40.2. In 2050, it's 150 years later. In 42.7. And in 2080 is 180 years later, 43.9. Okay, so executing. So this is going to give me my data. Okay, so we've copied this information across. So let's have a look what we're asked to do. So the first thing is to write the polynomial function. So write a polynomial function to model this data. So the linear regression, this is what we're looking at. Y is equal to a plus bx. So y, so we'll write f of x. Let's write f of x instead of y. So f of x. And we're going to write the bx first. So we look at this. So it's 0.126. And this is x. And we're looking at the a value, which is 22. And we're going to put it to 3 places. So it's plus 22.732. Okay, so then we're asked to estimate the mean. So we're asked to estimate the mean age of the population in the year 2005. So the difference, so 2005 minus 1900. So this is going to be 105 years. And we're just going to use 105 in place of x. So 0.126 105 plus 22.732. But when we put in the calculator, we have to remember we're going to use all of these decimal places. And then we will have an answer. So in the year 2005, the mean age will be 35.99, which is going to round to 36 years. Okay, and the final question says, according to your model, in what year did the median age of the population reach 30? So in what year did the median age of the population reach 30? So we're going to look at 30 and we're going to draw a line across and we're going to bring our line down. Now, this isn't going to be perfect because of my calculator. But here we're estimating this is about 58. So this is going to be in the year 1970. 1900 plus 58. So it's going to be in 1958.